So the question I want to discuss with you today is simple. It's just, will generative AI empower us or will it replace us? So the core issue now is not anymore if AI is powerful. We all know it is. The real question is, what does it mean for us, for our jobs, right? Should we be happy with it or should we be worried? So according to human resources experts, this year, 9 jobs out of 10 will be impacted by AI. So some of these changes will be positive, others will be negative, but the question also is what will be the global result, right? Will they be empowerment or replacement of workers? Because if you look at what the World Economic Forum says about it, so lots of jobs will be hurt differently, but also jobs that for highly skilled people. And at the beginning, you may think that there is an improvement in their position because they may be empowered by AI. In the sense that AI may help, I don't know, customer support or developers, software developers, or people doing trading, traders. They help them with the code, with understanding the environment, and so on. Okay, but at the same time, we see that there may be a move to automation, right, at the same time. Why? Because at the beginning, Google Translate or DeepL could help human translators, right? But now AI can translate entire books or technical documents. So this is something, this is a move that is happening right now. And understanding this move is crucial if we want to design good policies and good training for our careers. So now, if you look at this figure, so this figure depicts the wage productivity gap. So there is strong evidence among countries and periods about this gap. There is a gap. Why? Because on the one hand, in different countries and periods for different innovations, there is an increase in productivity in the sense of labor productivity of labor, right? And at the beginning, there is an increase in the wage, in the pay. And we understand that there is a link between both because the wage may be the marginal productivity of labor. But at some point, there is a disconnection between the wage and the productivity because a wage will increase up to a certain point, but then it will disconnect. And there are lots of explanations for this gap, standard explanations, but they are all exogenous to firms' decisions of innovation because these explanations are linked to, I don't know, globalization, unions, technology shocks, etc., etc. Right? But nothing is linked to the real innovation of the firm itself. So now, if we look at automation and wages, so I was interested in this book by Asimoglu and Johnson, who make the point that technology automatically does not always benefit everyone. Okay, so there may be cases when technology improvement benefits everyone or nobody, but it's not, there is no one way about it. So technologies may raise living standards for people, that's true, but it heavily depends on the institutions that we have, like unions, social protections, education systems. It also depends on the policies that we choose, like how we choose to tax, how we choose to make the competition happen, what are the labor rules that we apply, okay? And most importantly, it depends, the benefit of innovation depends on the direction of innovation. So are we inventing tools that complement workers, or are we developing tools that substitute workers? Okay, so that's a main point here, which also apply to AI. So if you look at their book, they explain that institutions matter in the link between wage and productivity. And they make a distinction between two kinds of labors. So forced labor and free labor. So forced labor, it is slavery, but not only, it may also be serfdom, etc. So here, when there is an increase in productivity, there is no wage increase. And the conditions may even worsen. Why is that? So that's a situation because people are not free and they cannot run away to ask for better conditions. And the elites would have an incentive to pressure workers even more to extract more rents, right? So this happened, I don't know, at different point of time in Middle Ages with the pillow, with the mills, where serf people endured longer working hours. In contrast, in a world where there is free labor, at the beginning, early on, when productivity increases, when the wage and working conditions, they also increase. Why? Because people are able to bargain. They are able to bargain, they are able to negotiate, and they are able to move if they are not happy. So it means that institutions matter, and again, in productivity alone is not enough to improve the conditions of the workers. But after some point, more often than not, we see in history a wage productivity gap. So this is what happened in the US since the 1980s in the digital area. So here, computer software and now AI have raised productivity, but lots of mid-skilled jobs like factory workers, administrative positions were automated or offshored. So the same happened for agriculture in the 19th and 20th century, where mechanization reduced labor hours per act dramatically, but the added value of labor fell dramatically. And the same in the early industrialization phase in the UK. So here we've seen luteal riots. So why? Because there was a mechanization in textiles, in the textile industry, that replaced skilled artisans, right? So here we had some conflicts, but still the wage productivity gap is not a fade. It's not a fade because, and we have several examples, historical examples that show that the wage productivity gap is not inevitable. So this happened in the early automotive ecosystem in the US. So here at the beginning of the 20th century, the car industry created new tasks. There were new jobs in steel, chemicals, retail, services, etc. The same in post-war US and Europe. So here we had strong unions, the development of welfare states, education expansions, and massive education expansions. So meant that many workers benefited from industrial growth. And the same happened more recently for Germany and Japan, where they created policies of retraining of workers and worker participation so that workers were still in place in the firm. So now we're going to understand all these features, especially the wage productivity gap, for which, to the best of my knowledge, there is no endogenous explanation, with a time model, so an economic model. And here, there are two main assumptions. So the firm engaged into R&D, innovation, and the team performs, on the one hand, task creation, and on the other hand, automation. So task creation is similar to product innovation. So it adds new labor performed task. It can, so human labor can perform new services, new features, new types of content, right? So this is close to product innovation that increases product quality. And there is the second L&D would be automation, so replacement. So here it is, there is automation when there is a shift of the tasks assigned to workers that are automated. Okay, so so AI perform existing tasks that were previously done by humans. So this is here process innovation, which tries to reduce the production cost. Okay, so here we try to, with automation, we reduce the production cost, and with task creation, we expand the task frontier. So all the possibilities that can be done. And the main results will be the following. So first, we see an already sequence between task creation and automation, so an endogenous sequence. And this sequence can explain the wage productivity gap, right? And also, we have different ideas about the welfare policy implications linked to this sequencing of R&D. So the positioning of this research is the following. So this research builds on two literature streams. And the first literature stream is on automation and on wages, which often takes the timing of innovation as given. So here in this literature, people start automating existing tasks at some point of time, but without explaining why they would do it. So here they have a what of the productivity wage gap, and the welfare analysis is ambiguous in general, and there are policies, recommendations, but the debate is more about if we should tax up subsidy robots or AI. And there is another literature stream, which is the industry life cycle. And here, this literature is mostly descriptive. It's mostly descriptive, and there is a sequencing of product innovation to process innovation. So first, the firm engages into product innovation to develop new features for the product so that the product match the market and the needs of customers. And when this is done, then the firm engages into process innovation to reduce the production cost. Right. And here there is no discussion of wage, welfare, or policy. And this research, so we endogenize the timing of automation, and we link it to the wage productivity gap and to the policies. So here in this research, we have the why of the productivity wage gap within the firm innovation policies, and we can derive welfare-based rules and a stage-contingent policy. So the industry context is the following. We consider an industry with several firms producing differentiated goods. So there is monopolistic competition a la Dixit and Stiglitz. That is, each firm faces competitors, but because products are imperfect substitutes, so each firm has some market power. Okay? Then there is firm symmetry, which allows us to focus on a representative firm. So this allows us to keep the analysis tractable, but still keep the main economic mechanism for us to understand, right? And the representative firm makes two intertemporal decisions. So the first is to invest in R&D for task creation, so which expand the set of activities performed by the worker. And the second is automation, so which replaces existing labor tasks with machines or AI. Okay, now for technology and tasks, there are two state variables. So first one is N, it is the number of tasks that exist in the firm. So you can think of tasks as distinct activities, services, production steps that together make the output of the firm, right? So task creation therefore expands the scope of production. The second state is A, it is the automation share, automation share. So this is the share of tasks that are automated. So when A is 0, all tasks are performed by human workers. right? But then if A equals 1, it means that all existing tasks have been automated. So production here combines labor and machines, and labor performs the, the fraction of tasks that have not been automated. And machines perform the fraction of tasks that have been automated, right? Also, automated tasks are more productive, and a machine performs a task times more efficiently here than a human worker. So here in this setup, the wage is the marginal productivity of labor. So you see that wage depends only on the number of non-automated tasks, right? And second, the productivity. So what we call here the productivity, which is in fact the average productivity of labor, depends on both the number of tasks here and how many of them are automated, right? Then we perform some classical normalization to investigate the policies of the firm. How do R&D policies evolve over time? So there are two controls, two decisions, two controls by the firm. So RN is investment in task creation, and A is the investment in automation. So you see that when you invest more in M, it raises the number of tasks N, but with diminishing returns and some depreciation over time. For automation, it is a similar motion law, yet there is some a saturation effect. So when you invest into automation, it will increase the automation share, but with diminishing return and a saturation effect. And what it means is that if almost everything is already automated, it will be much more difficult to automate more, right? Whereas at the beginning, if almost nothing is automated, it's much easier to automate. So this will drive an S-shaped diffusion pattern. And then there is a cost of these R&D decisions, and that's a quadratic cost, which allows for a tractable problem. Let's move now to the operational profit flow. We use a reduced form for operational profit. And here, profit is proportional to output. So this is used by Dixit and Stiglitz. Profit is proportional to output with a constant net share here. And then there is a fixed operating cost. And this parameter M of profit share captures imperfect competition. And also it allows to have positive operational profit, which in turn will be able to finance R&D expenditures. Okay, so, so the representative firm chooses at each point of time how much to invest in task creation and automation. The objective is to maximize the present discounted value of profits over an infinite horizon. So in Satanus profits, we have two components. The first one is the operational profit, and the second one is the cost of R&D, right? And of course, the cost, the firm in deciding accounts for the dynamics of task creation here and automation. So let's move now to the results. So the main theoretical results following, which is a film sequencing of R&D. So we show that there is a unique, endogenous, and irreversible switching time tau. So before this switching time tau, there is only task creation. So the firm only invests in task creation, right? And don't invest at all in automation. And after this switching time too, the firm only invest in automation, right? And so why? So what is the economic rationale for this? So in the early stage, the firm focuses on creating new tasks, new products, services, feature, business line, whatever. And then this is when the firm expands its task frontier, right? And as the number of tasks grows, the marginal value of creating another task falls. So many opportunities have been exploited. So the low-hanging fruits have been taken already. And at some point, the return to automating existing tasks become higher than the return to discovering new ones. So at this time, the firm switches from task creation to automation. So that's the switching time too. And after the switch, the firm concentrates on automation. So it uses AI and machines to perform tasks more cheaply and efficiently, right? And there is no coming back. There is no coming back. Even though automation faces saturation, task creation will never be optimal again. So let's illustrate these elements. So we see here that the number of tasks rise rapidly at the beginning till this switching time too. So this is where we have an expansion of variety, and so that's a task frontier, right? And after some time, you see that it will not move at all. So there will be no creation at all. So this part is in the age of AI. It is, I don't know, when data scientists can use AI to create more data, build models, supervise AI outputs. When they are learning to perform new tasks more quickly or in a more reliable way. After this time, though, we see that that automation starts, right? So here, that's the start of automation, and there is no more investment in new tasks. At the beginning, so automation was completely flat. There was no automation, and then it rises steadily, right? And early on, the firms, so they expand on what they do, and then here now it's time to optimize. So it's time to labor cost, right? Here it is, I don't know, it's time for, in the age of AI, to not use human translator anymore, but to use solutions, AI solutions. The same for coding. Now you may wonder, what are the determinants of this switching time too? And here's that time to perform some comparative statistics. And so the switching time too, so it equalizes the marginal returns to task creation and automation. And it is impacted by, of course, all the parameters, but the most important are the following. So net profit share, M, so it increases the profitability of task creation relative to automation. So it implies that there is a later switch. So it means that a highly profitable firm with a strong brand may stay longer in the variety creation phase. Now, if you look at task creation productivity, so here phi n, it raises the value of creation. So that's true. It makes the creation of new tasks easier, but it also raises the value of its future automation. So eventually the effect is ambiguous. The effect is ambiguous because it increases both the value of creation, but also of its future automation. And if you look now at how easy it is to automate, and how productive machines are. So this will incentivize automation, and this will drive earlier switch. I was thinking when I was doing this model, so now it's a little bit beyond the scope of these results, but maybe there would be a third sequence, right? Not at all model here, because thinking about my own experience, at the beginning, I've seen people using a human copy editor for their academic text, and then they were using Grammarly, like it's a special purpose AI, and then they replace this special purpose AI with a general purpose AI like ChatGPT. So in fact, I was thinking that even machine could replace machine. Let's now consider a little bit the wages, if you want to understand the wage productivity gap. So in this model, the wages, so the wage is the marginal productivity of labor, and it depends on the number of non-automated tasks, right? And in contrast, productivity here depends on the number of all the tasks and on the automation share. So now we can summarize the dynamics as follows. If you look at the evolution of wage over time, you see that it depends here on task creation. So, and that's the first stage. In the first stage, in the task creation stage, so this is positive, and there we will see an increase in wages, right? Whereas in the second stage, when it is the automation stage, this is null, and only the second terms matters. And here, automations will lower stages. So that's why in the second stage, we will see decreasing wage, right? That's different to productivity, because with productivity, you see that productivity increases in both stages, right? So whether the number of tasks increases, then productivity increases as average productivity of labor. And if automation increases, then productivity also increases, right? So the result is that we can predict wages that follow an inverted U-shaped curve. So first, wage increase and then the decrease, whereas productivity increases monotonically, right? So this it means that the wage productivity gap emerges endogenously. There is, let me repeat, so the wage productivity gap here emerges endogenously due to the sequence of R&D by the firm. So it does not appear due to, I don't know, unions, bargaining power, or institutions, right? That's a structural consequence of how firms optimize innovation. And if you want to illustrate this, you see that we have here wages and productivity. So wages is marginal productivity of labor, and productivity is average productivity of labor. And you see that the productivity line, so it always increases, right, irrespective of switching time, whereas the wage line, so it rises first and then it decreases, right? So you can see that this phase would be the empowering phase of AI, when we have new tasks, new jobs, rising wages, and so on. And the second, and the part on the right is the replacing phase, when automation dominates, right? Productivity continues to grow, but wage decline, right? So the policy challenge would be to understand this switching point, and to see if we should do something about it, and then why, and then what. So this leads us to welfare considerations. So we define social welfare as the sum of consumer surplus. So the benefits of buyers, if they get lower prices and better products, labor income with wages, and capital income with profits. So the government goal is to maximize welfare, not just profits. And we have here a welfare-based sequencing rule. So with 4 stages. So at the introduction stage, when the industry is young, it is socially optimal to subsidize task creation, right? Because new tasks bring large benefits, and the wage effects are positive because wages increases, right? And then there is a growth stage. So at the growth stage, so that's an intermediate stage. And here, neither more creation nor more automation clearly improves welfare. So the best policy may be not to subsidy, right? And we let the market operate here. In the maturity stage, when the industry is mature and many tasks already exist, we may obtain more welfare gains from automation if the benefits in consumer surplus outweigh the wage loss, right? So it may become optimal to subsidize automation. So here, the trade-off may be more between on the consumer side and on the labor side, because when there is more automation, consumer surplus may increase because people may pay lower prices. So the consumer is happy. And if this effect is strong enough, it may outweigh the labor income effect, which is that wages decreases. So now there is a fourth stage, a decline phase, for which the government may subsidy task creation or automation, or both, depending on which one has a stronger impact. Right. So an implication is that we should have, if we perform a policy, it should be stage-contingent. It should not be a uniform policy. It should not be a uniform policy that would be inefficient. And we see that the policy of the government follows the firm sequence, but it's not exactly the same, because the government is not just maximizing capital, it is also taking into account consumer surplus here and wages. So this figure summarizes the welfare role in a more special case than the one presented for the proposition. So on the horizontal axis, we have R over N. So this is revenue per task. So it is a measure of industry maturity, right? And on the vertical axis, we have welfare-based recommendation, right? Here, welfare-based recommendation, and here is the level of automation. So as the industry matures, so we see that the equilibrium path, so at the beginning, there is no automation. There is absolutely no automation in the industry. And then the automation starts, and automation increasing, and it never stops, right? And here 3 is the level of chi, so the relative productivity of machines. So it stops there. So the equilibrium paths, so it moves, or the firm, it moves from the left to the right. And early on, the welfare-based advice would be to support task creation, because even though the firm already engages into automation, from a welfare perspective, it is better to support, still support task creation, right? And then there is this threshold, which is a neutral zone, given by this threshold here. And here the government should not subsidize anything. And after this threshold, the government should support automation, because here what we lose on wages is compensated by what we gain on lower prices, right? So again, it illustrates the idea that one-size-fits-all policy is inefficient, right? So taxing or subsidizing robots or AI in the same way at all stages of industry is not optimal, and instead, so policy should be stage contingent, and it should be technology specific. And of course, that's very easy to say from a theoretical perspective, and for a regulating perspective, it may be more complicated. So now, what can we say about the welfare effects of automation. Because look, let's decompose the welfare effect of automation. And here you see that an increase in automation, it can affect welfare through profit channels. So the first channel is consumer surplus. So by lowering production costs, there will be cost reduction and then a lower price, right? So this would push to an earlier threshold of subsidizing automation. Now there is a second channel, which is capital income. So it depends on market structure, and a priori the effect of automation on profit is ambiguous. Even though in a competitive market, the derivative here is null. So if we operate in a competitive market, so this guy disappears, and the welfare effect of automation only depends on the trade-off between consumer surplus gain and labor income loss, right? And the third channel is labor income. So here, automation, it reallocates tasks away from workers, and this reduces wages. So the loss is proportional to the size of the task base. And when many tasks exist already, like M, additional automation so generates larger wage loss, right, which delays the point at which automation becomes interesting from the perspective of the worker. So let me conclude now, and I would say that generative AI is pushing us from a world where machines were mainly tools to a world when they can be co-workers and sometimes competitors. Right, so will generative AI empower or replace us? To come back to our initial questions, so the honest answer is that it can do both. So it will empower those who learn to use it as a copilot, who develop complementarity skills, right, who adapt to it, but it will replace those who don't add value to AI and who become just substitutable to AI, right? And I will finish by stressing that the greatest risk for us is to wait and do nothing, because if we do that, we will never adapt our skills nor our policies. And in this situation, switching to automations, it's just a matter of time. Thank you.